Dear students, today I am solving some problems. So before solving the problems, you must go through the all important formulas in this topic. The first formula is acceleration due to gravity G equal to Gme upon Re square. Sometimes you can write it as a Gm upon R square also. And according to this formula, I can remodify it as Gm E equal to small gr square. Then value of acceleration due to gravity g at a height h from the surface of earth can be written as g dash equal to g upon 1 plus h upon re, and there are two different formulas for this value of g at a height h. If height is very small, you can use this formula g dash equal to g upon 1 minus 2h upon re. So small means approximately 5% of radius of earth, which is approximately 320 kilometers. Up to 320 kilometers you can apply this formula, and for remaining height you can use this formula g upon 1 plus h upon re whole square. Then the value of acceleration due to gravity at a depth d. The value of g at a depth d can be written as g dash equal to g into bracket 1 minus d upon re, where d is depth. Escape velocity ve or v minimum, both are correct. So root of 2g re plus h, you can write it as 2g re also by omitting this h value. If you are calculating the escape velocity from the surface of earth, just you have to write root of 2g re instead of writing re plus h. So potential energy of the satellite u equal to minus gmem upon re plus h, where me is the mass of earth and small m is the mass of satellite, and h is the height of the orbit in which the satellite is revolving around the earth, and re is the radius of earth, g is the universal gravitational constant. Then orbital velocity VO equal to root of gm upon r. You can write it as gme upon re plus h also. And according to this definition here, acceleration due to the gravity, according to this definition, gm equal to gr square. So you can use this formula. So instead of gm, you can write gr square divided by, as it is, r plus h. So root of gr square upon r plus h is also the orbital velocity. And finally, the time period of satellite t equal to 2 pi root r plus h cube divided by gr square. So these are the very important formulas. If you remember all these formulas, then it will be easy for you to solve the problems. So let us take first problem. The planet Mars has two moons, phobos and demos. So phobos has a period 7 hours 39 minutes and orbital radius 9.4 into 10 to the power of 3 kilometer, and you have to calculate the mass of Mars. Mars is a planet, you have to calculate its mass. So formula is very simple, you have already gone through it. T equal to 2 pi root r plus h cube divided by gr square, and you can write it, instead of gr square you can write it gm, and if you square it, it becomes t square, and all these terms get squared. So 2 becomes 4, pi becomes pi square, and r plus h cube upon gm, it will come out of the root. So gr square, instead of gr square I have taken gm because I want the mass. If you write gr square, then I won't get any the term related to mass. Then if you rewrite this equation as m mass of Mars equal to 4 pi square upon g r cube upon t square, then you have to put all the values. Given values are substituted here. 4 into 3.14, pi value is 3.14 square, then 9.4 into 10 to the power of 3 kilometer is the orbital radius. You have to write it here, cube value, and 10 to the power of cube means it will be 18, then divided by G value is 6.67 into 10 to the power of minus 11, and 459 into 60 is the value of this time period in seconds. Here they have given 7 hours 39 minutes, so you have to convert 7 hours 39 minutes into seconds. 1 hour means 60 minutes, so 7 hours means 7 into 60, that many minutes. Then 39 minutes is there, you have to add it, then you get to 459 minutes. If you multiply 60 with 459, then it will be converted into seconds. So you have to take the time period in seconds according to SI system, the square value. Then you have to simplify this formula, then you get the answer 6.48 into 10 to the power of 23 kilogram. So whenever you take the power 10 to the power of minus 5 to numerator, minus 5 becomes plus, and you have to simply add and subtract the powers when you are multiplying 10 to the power of 18 or 10 to the power of minus 5. So for example, if you take this 10 to the power of minus 5 to the numerator, it becomes 10 to the power of plus 5. While multiplying this 10 to the power of 5 with 10 to the power of 18, you have to simply add the powers. 18 plus 5, 23. So the same power is written here. So now we go to second problem. Problem is calculate the mass of Earth using given values. G value is 9.81. They have given 9.81, not 9.8 meter per second square. Radius of Earth 6.37 into 10 to the power of. Radius of Earth is given as 6.37 into 10 to the power of 6 meter. The distance between Moon are equal to 3.84 into 10 to the power of 8 meter, and the time period of Moon's revolution is 27.3 days. So 3.84 into 10 to the power of 8 meter is the distance between Moon and Earth. So simple formula is you have to calculate uh, the mass of Earth. So from the definition of acceleration due to gravity, G is equal to Gme upon Re square, or Me equal to, we want the mass of Earth. Just rewrite this equation for Me, that will be equal to Gre square upon capital G. So capital G, because G upon, so they have to substitute the values. Value of G is 9.81, and Re is 6.37 into 10 to the power of 6 whole square, divided by capital G value is 6.67 into 10 to the power of minus 11. And sometimes it is given and sometimes it is not given. You have to remember this value of G. So if you simplify, if you take this term 10 to the power of minus 11 to the numerator, it becomes plus. And if you square 10 to the power of 6, because it is square, it is here, it becomes 10 to the power of 12 plus 11, so it will be uh, 23. And while multiplying all these values, you get one more power, it will be added here, 10 to the power of 24. So answer is 5.97 into 10 to the power of 24 kilogram. And you have to practice it. If you have any doubt in calculating this value, you can ask it in the doubt clarification session. So third problem is, what is the acceleration due to gravity 1400 kilometers above the surface of Earth, whose radius is 6400 kilometer? And the G value is given, and it is asked in March 2013 for 5 marks. So we already know the formula. G dash is the acceleration due to gravity at certain height. Here the height is given 1400 kilometers. This height is more than 5% of radius, so we should take this formula, G upon 1 plus h upon Re square. This is for large height, and this is the formula for small height. We are not taking this. And if you put the values, small g 9.8, 1 plus h value is 1400. It is not simply 1400 meter, it is 1400 kilometer. So you have to multiply 10 to the power of 3 divided by 6400 kilometer means again you have to multiply 10 to the power of 3, then it will be square. Here it is 9.8 upon 1 plus the value of this is 0.22 whole square. 1 plus 0.22 whole square means it will be 1.488. So 9.8 upon 1.488 equal to 6.58 meter per second square. Now we go to fourth problem. Find the difference in the value of acceleration due to gravity at a height of 2500 kilometers above the surface of Earth and at a depth of 2500 kilometers below the surface of Earth, and the given values are g equal to 9.8 meter per second square and r equal to 6378. This question is asked in March 2014 for 5 marks, and you have to simply calculate the acceleration due to gravity at a height of 2500 kilometers using the separate formula, and you have to calculate the acceleration due to gravity at a depth of 2500 kilometers below the surface of Earth separately. Then once you get the result, once you get the value for this height and depth, then you have to take the difference between those two values, then you have to write it as an answer. So at a height of 2500 kilometers above the surface of Earth, you have to use different formula, and at a depth 2500 kilometers below the surface of Earth, you have to use a separate formula. So the formula for calculating this acceleration due to gravity for a height 2500 kilometers, it will be g dash equal to g divided by 1 plus h upon re whole square. Just you have to put the values 9.8 divided by 1 plus in place of h you have to write 2500. Since it is in kilometer, you have to write into 10 to the power 3, and the value of radius of Earth is 6378. It is given, it is also in kilometers, so into 10 to the power of 3 you have to write and whole square. Then if you cancel 10 to the power of 3 and the if you divide 2500 upon 6378, you get to 0.39, and it will be g equal to 9.8 divided by 1 plus 0.39 whole square. Then if you simplify this, then you get to 5.08 meter per second square. Then for the depth, the formula is g dash equal to g into bracket 1 minus d upon re. Then you have to write the value of g 9.8, then value of d is depth is also 2500, it is also in kilometer, you have to multiply 10 to the power of 3, and the radius of Earth is 6378 kilometer 10 to the power of 3. Then simplify it, this term will be 0.39, 1 minus 0.39 multiply 9.8, and you get to 5.98 meter per second square. And the difference between these two values is 5.98 minus 5.08 equal to 0.9 meter per second square. And the last problem is calculate the orbital velocity and period of revolution of artificial satellite of Earth revolving at a height 200 kilometers from the Earth's surface. Given values are radius of Earth equal to 6400 kilometers, mass of Earth is 6 into 10 to the power of 24 kilogram, and gravitational constant g is equal to 6.7 into 10 to the power of minus 11 Newton meter square per kilogram square. So satellite is revolving around the Earth at a height of 200 kilometers, and you have to calculate what is the orbital velocity and how much time it is taking to complete one revolution, that is period of revolution. So this problem asked in 2018 February for 5 marks. So orbital velocity formula is root of gm upon r plus h. In place of gm, you can write gr square according to the definition of acceleration due to gravity. But instead of gr square, you have to write r plus h whole square because it is at a height 200 kilometers. You have to include height also. Then if you get cancel the term r plus h, then leaving v naught equal to under root g into bracket r plus h, and put all the values 9.8 into 6400 plus 200 into 10 to the power of 3. This is also inside the root, not outside the root. And if you rewrite this 6400 as 6.4, then you have to multiply 10 to the power of 3. It becomes 6.4 into 10 to the power of plus 3. In the same way, 200 can be written as 0.2 into 10 to the power of 3. So common multiplier is 10 to the power of plus 3. If it comes out of the bracket, it will be multiplied with this existing 10 to the power of 3. It becomes 10 to the power of 6. Once it comes out of the root, it becomes 10 to the power of 3. So here, if you multiply 9.8 with 6.6, it's a 6.4 I have taken, and here I have taken 0.2. 6.4 plus 0.2, it will be 6.6. 6.6 into 9.8, it will be 8 under root. If you take out the root, then it will be 8.04 into 10 to the power of 3 meter per second. But I have expressed this result in kilometers. 8.04 kilometer per second. As far as this time period is concerned, you have to use this formula: t square equal to 4 pi square upon gm into r cube. So wherever r is there, you have to put r plus h, because the satellite is at a height 200 kilometers. So 4 pi square, because it is a t square value, if you write it for t value, it will be under root 4 pi square into bracket r plus h cube divided by g into r plus h square. So these two terms get cancelled, leaving only 4 pi square into bracket r plus h upon g. If you put all these values, 4 into 3.142 whole square, 6400 plus 200, you can rewrite this 6400 as 6.4 into 10 to the power of 3, and 200 can be written as 0.2 into 10 to the power of plus 3. And if this two common multiply 10 to the power of 3 comes out of the bracket, it becomes 10 to the power of 3 into 10 to the power of 3, it becomes 10 to the power of 6. So once it comes out of the root, it will be 10 to the power of 3. So with all these calculation in your mind, you have to simplify it, then you get the result 5.2 into 10 to the power of 3 seconds. Then you can use the then you can calculate the time period using the second method. This method is very easy. So time period t equal to circumference divided by orbital velocity. So circumference is 2 pi into bracket r plus h divided by orbital velocity. And if you put all the values, 2 into 3.142 into bracket 6400 plus 200 is a height. Since this radius and height are in kilometers, you have to write power 10 to the power of 3 divided by, you have already calculated the orbital velocity 8.04 kilometer per second. Since it is in a kilometer per second, you have to write again multiply 10 to the power of 3. And if you simplify all these values, then you get again a 5.2 into 10 to the power of 3 seconds. This is one method, this is second method. I think second method is very easy because you already calculated the orbital velocity, the same value you are taking here, and for the both method you are getting the same answer. And you have to practice similar problems in your textbook or any reference book. And if you have any doubt in these 5 problems, so you can clarify it in your doubt clarification session. So with this, I am completing the chapter gravitation.